Hi, it's Gadget UK here again, back with a C64 power supply. You can see it's got some dust and fluff on it. It's had an impact here. Something's loose on the inside, which is never a good sign. And it's kind of started to prise open here. Can you see this? Probably from the impact. So these are not really serviceable in the sense they're usually a load of epoxy, all over the transformer, the components on the inside. But yeah, generally if you sort of try and prise these open, they will snap off. It's proven quite difficult. Let's see if I can see what's loose in there. It might be the board. I don't know, something's rattling in there, look. Sanity check, it is unplugged. That's just for a minute there, I thought it was still plugged in, but it isn't. So yeah, the least damage you can, if you can, there you go, avoid doing too much damage. Yeah, that post there's broke off. As you can see, it's just a solid mass of epoxy. So there's very little you can do with these, but you can swap the regulator out. You can literally dig out that regulator out there, replace it, replace the caps and things on here. All you've got generally down here is the transformer. So I think the transformer's okay actually. So I think we'll be able to repair this, and then we'll have to, let's say, epoxy the points around the edges and stuff, and epoxy the base back on. So it'll never be perfect again, but it should work. Your best thing to do is to just get an alternative power supply, probably, because there are modern power supplies you can get for the C64 now. Anyway, the first thing we're going to do here is just desolder the 3 points on the regulator there. In fact, we can measure. Let's just have a measure while it's like this now. Let's have a measure and see what voltages. We should have DC, 5 volts DC here. If the regulator's on its way out, we will see higher voltage. Now, I measured this a minute ago and I could have sworn it was outputting about 7 volts on the 5 volt line, but that might just be me not measuring it properly, because it's quite hard to measure the power out the connector directly. So I've got the meter on volts DC. I need to change the battery actually, and if we measure these contacts here, yeah, look at that, 7 volts. 7 volts on the 5 volt line. So yeah, that's not good. If you connected that to your C64, you're going to get problems. That might explain why this particular C64 had a troublesome SID, because it's had 7 volts power in it instead of 5. An interesting thing not many people realise, the CMOS chips actually on the C64 are rated to go up to about 7 volts. So you won't just instantly kill them on a power supply like this, but you really don't want any more than 5 volts, because there are some standard 7.4 series which don't really like much more than about 5.5 volts ish. So the regulator definitely needs swapping out. So let's desolder the regulator here first of all. I'm just going to use the desolder pump here that was provided to me by Andrew Littleboy. I'm adding a little bit of fresh solder and flux there just to make it a little bit easier to remove. Yeah, there we go. So that should mean, we'll just give these a little wobble here just to make sure that it's detached. It's only going to be a single-sided PCB here. There we go, that one snapped off. It just means now we can lift this up. Now let's just desolder those as well actually. I'd forgotten, you've got the windings here from the transformer. Just get as much solder off there as I can, because then you can kind of just like lift them up a little bit. You can see that one's free now, so I'll do the same with that one. This is where you might need a little bit more heat on your soldering iron. There you go, that's that one off. Those two it's not so much of a problem with, because it's AC, it doesn't really matter which way around. These are ones that is important. The white is near the top because, well, one of these is ground, one of them is 5 volts. So yeah, just flip that one off, that's off. Let's do the same with this one. You don't really need to suck up all the solder like I'm doing here, but why is that not melting now? Just makes it a bit easier to get off if you suck it off. There we go. So just have to remember green at the bottom. There we go, and those two there I think are free. Yeah, there we go. So that should mean this PCB should come out now, I think. pull it over there, over the 3 pins. There we go. Yeah, look at that. That cap was hanging on. Look at that. It's not even on there. Yeah, that's going to be a big part of the problem. Look, the pad's ripped here. It's going to be for the impact. I mean, that's not going to be reason why it's outputting more than 5 volts. Anyway, let's just get rid of that. We can always just bend the leg over and solder onto here. So let's just heat that pad if we can. Just pull it through. There we go. That pad is may as well just come off there. It's not a big deal. So what we do now is trim all these long bits down, reflow the points for the things that are on there. So we're going to need a new cap, aren't we? That's for sure. What size is that? 4700 16 volt. Yeah, it smells a bit crusty, that as well, actually. Yeah, I always sniff sniff these things. Here we go. Let's see if we can just get that off. That leg. I'll tell you what will make it a bit easier. Let's just trim its crazy leg off on this side. And then when we heat it, it'll come off a lot easier. Let's just get rid of all of these though, because they're all ridiculously long. I don't know why they didn't trim these down at manufacture, really. Let's just resolder these points here on these diodes and stuff. The original flux is awful. You can see that that's just floating. There we go. It's not going to do any harm to have a little bit extra solder. That's that wire. See if we can pull that out. Yeah, there we go. That's out. Let's just unblock that. Let's just unblock that hole for the replacement cap. There we go, that's all those points resoldered there. Let's check those diodes. So the meter's on diode test here. Stick the red side to the anode, that's the side without the band, and the black probe on the cathode. You can see we're getting 0.499 roughly there. Swap it round. Nothing, that's correct. That one's alright. That one's okay. And the final one, yeah, that's okay as well. And then the 2 resistors here, and the resistor there is red, purple, brown, which is 270 ohms, I think. There you go, you can see that's okay. And the one on the other side, there's a tantalum here, just make sure that's not short in a sec. And this one here is brown, red, black, so that's 12 ohms, is it? Yeah, 12.5 ohms, look. We'll just make sure that that there is not shorted or something. Yeah, it's not, is it? It's just across the resistor there. So these resistors are used to tweak the voltage actually. You can see they kind of go across some of the connections related to the voltage regulator here. You can do that with some of the 7805s. You can tweak them slightly. I mean, we'll clean this as well because you can see it looks a bit awful. But what we'll do now is see if we can remove the regulator from the epoxy and see if we can mount another regulator in place of it. Now, if we can't get the regulator out there, it could be game over for this, but I just want to show you, just reconnecting it. We've got the capacitor in place, I've got the connections here for the DC out, and if we measure it now, just temporarily reassembled here, just look at the DC out now. It's nearly 11 volts, so yeah, if we had that connected to a C64 now, we'd be feeding 10 or 11 volts into the main logic there. It'd just fry everything. So what can we do? Well, you can see I had a go with a screwdriver here. This is super hard, this epoxy. It's rock solid. You could try and Dremel around there a little bit to try and get it out. I suspect it might be screwed onto the heatsink. The problem is this epoxy, can you see, it's all the way around the whole thing as well. So you're never easily going to get that regulator out of that cavity there. I think the best thing to do is to trim the legs right off, because we know that's the issue. It's screwed. Trim it down. Gives us a little bit of clearance inside. And then I think on here we'll fit one of those recom devices. You can see I've got a cap there just temporarily. What we'll do with this is just stick it down, put a bit of heat shrink tubing right around there, and that'll be fine. It fits into that cavity nicely. But we'll get a recom DC to DC converter and fit it there. Maybe extend it out this way or something so it'll sit over the top of there, but they don't get hot. If you were to put another 7805, it needs to be heat sunk, and we can't get something onto that heat sink easily. You might be able to if you put it sort of sideways here, drill a hole through there and mount it here, and then extend out to, you know, so you could, there's ways you can do it, is the point I'm trying to make. There is enough clearance there to fit one sideways, but I would imagine it pretty hard to try and drill a hole through those two things there. You might just be able to do it at this angle, I don't know. Anyway, let's try a recom DC to DC. Yeah, it's made by a different company. It's not a recom, it's, well, it might be Traco Power TSR 12450. So I'm pretty sure this is a 5V DC to DC, so we've just got to get pin 1 the right way around. I'm trying to think about it now. It's probably going to be that way. I'll just have a look at the pin out for this in a minute. It's going to be difficult actually because the legs are short, as you can see, but what we might be able to do is just mount it like that there. Yeah, that's probably going to be the easiest thing. If anything, it's stood away from the heatsink a little bit then as well. Yeah, there we go. Pin 1 at the top, that's the input. The middle pin is the ground, and the third pin there is the output, which is where it's going onto the, you know, the connector would have gone over here. So if we just carefully get this into position here now, I'm going to test this. I'll do the heat shrink bit on that cap in a minute. I want to just see, because the thing is, this particular one is only capable of 1 amp, which may not be enough. You really want probably 1.5 amp. The one that's already on there would be the CV model, 7805 CV probably, which is rated up to 1.5 amp. But I could always order another one of these. I think there's like a 2 amp one or something. I might be able to order one of those. Now let's just measure the DC voltage coming out here now. Yeah, there we go, look at that, 5.02. So, I think that's okay. Bear in mind, if you do something like that, those 2 resistors on the underside, they may need removing. I don't think it's going to cause any problem for the moment. I'm going to reconnect those leads. I can't remember which way round they go. I'll have to look back at the video footage. I think it was white nearest the top, but it might not be. And then going to go test it and see how stable it is and whether we get any noise or anything from that DC to DC coming across on the sound or picture. So you can see I've just got it sat there plugged in that way just for testing, because I suspect we're going to need a higher current device. And if we just measure on the corner pin of that chip there, so that's the 5V line, you can just about see the meter there. If I switch it on, just watch, I get a black screen. See that, 0.4 of a volt? That's with the saver in between. I'm not powering this straight into the system here, as you can see. I've got the saver here. If I remove that, I know the voltages are okay because I have measured them as well. And if we do the same thing, get that 0.4 of a volt. So that DC to DC is not up to the job. We need something a bit beefier. So as you can see, we've got the DC to DC there, and I've got a voltage display, and now this works. If I switch this on, just watch. It powers on, system's working, but look, we've got 4.75 volts there, not 5 volts. Now if I switch it off, I just want to show you, this is about voltage drop across the cable. This is the reason why some of these power supplies have got those couple of resistors across the couple of pins there. You can like tweak the regulator so that it outputs slightly more than 5 volts, and that's exactly what those resistors were doing. I removed them actually as part of fitting this. They won't work with this the same way, I don't think. If I switch this on and put the meter there, and if we measure the contacts here, I'll show you, 4.75 there. But if we measure the contacts here, let me just see if I can hold this and I can show you the meter. You can see that 4.92. So we've only got a tiny bit of voltage drop there, but by the time it gets to the C64, we've got a lot of voltage drop. So what can we do about that? Well, 4.75 is too low. It needs to be 4.9 at least, I would think. I'd be happy if it was 4.95. So faced with no alternative, I have drilled a hole through here, and I'm going to mount the 7805 on here. I might need to cut this back a little bit because I'm not sure that's far enough along here. You can see all the shavings here from the aluminium. I'm just going to hoover this out now. So as you can see, I've got a screw here and it's threaded through the heatsink. I don't even need a nut on it, it's been really tight. You can see it's pushed the plastic a little bit there, but it's proving very difficult to turn that because it's threaded, let's say, through the heatsink. So all I need to do now is get some heatsink compound, and I'll just pull that back out. Yeah, I've got some heatsink compound on there. Join it to the heatsink, and then I'll attach 3 wires and heat shrink them. So it's very fudgy, but it will get you out of a pickle, because otherwise you need to just replace this entire PSU really. So I'll just get a little bit of thermal paste here. We don't need masses because it's just going to get squished out. So if we just sort of squish that into position, I think, and then try and get the screw in. Yeah, as you can see, I've been able to fit the nut there. Let's get that super tight. Yeah, I don't think it's going to go much tighter than that. So that is well and truly stuck onto the heatsink there, and we've got that thermal compound as well. There we go, so our 3 wires done. So I've got the hot air about 150 degrees here. We'll just shrink the heat shrink. These wires are not going to be left that long, it's just while I get the board back in and just feed the wires up to the top side. There we go, that'll do. And there we are, reassembled, and if I measure the voltage here now, you'll see 5.25 volts there, almost 5.3. That's because of those 2 resistors which I've reinstated. So that should be working. Let's go give it a try. So again, I've just got it exposed like this for testing. Switch it on. I'm going through the saver, by the way. I wouldn't just risk plugging any old power supply in like this. I'll show you that in a second, but you can see there 5.07 volts. So I'll test this for a period of time, but I think we're done. Just need to find a way to secure the base on now and just clean up the underneath the PCB before we do that. But as you can see, it is working. This just goes in line. Yeah, 5 volt saver from Bawak. I'll post a link down below. I don't think he's selling these himself, he may well be, but I think he's kind of open sourced it. This might be an early version, I honestly can't remember. There's like 2 or 3 or 4 versions of this, but yeah, switch it on, powered on now. But yeah, if the voltage is above about 5.5 volts or 5.4 volts, this just cuts off, won't allow the power through. So it's a good idea to get something like that if you're using one of these original bricks like this. So I can just clean up the flux off here now. You can see I've put quite a lot of solder on those winding connections there. You know, that's where the AC comes in to this power supply PCB here. So it's got a brand new 4700 microfarad cap on there, a brand new 5 volt regulator. It's the CV 7805 CV. It's important to use that one because that provides more current. It's like 1.5 amp, I think. I'm pretty sure that's similar, if not identical, to what would have been on these originally. It's, from my experience, it's rare for the 7805 to short like this one, you know, did do, but it does happen. When I say it's rare, everybody said it happens, so it's not that rare. But what I mean is, you could buy 20 power supplies like this that are described as faulty and find 2 or 3 of them with a regulator problem like that, and the other ones it just needs a recap. But I would swap out the regulator while you're there. The C64 power supply I've been using, I replaced the cap on it when I first got it, and I've been using it for 7 or 8 years now, no problems at all. But I wouldn't use it without a 5 volt saver. It's always a good idea. I nearly forgot there actually to put some heat shrink on that wire there that goes on the cap, and to secure that cap down. I'm going to use one of those 3M double-sided sticky sponge things just underneath the cap there. That should just hold it in place so it doesn't wobble around. You could always drill a hole through the board and secure it with a cable tie, actually. if I had my drill out, I might do that. So what I mean by that is, like here for example, there's no PCB or anything, no components on that area there. In fact, no, there's a big hole, look. So you could drill a hole there, stick a cable tie. Do you know, I might just do that. I'm going to use my track cutter, cut a hole there and stick a cable tie around it to hold it in place. That's the best thing to do. Yeah, there you go. You can see I've drilled a hole. I'm just going to vacuum that. And we'll try and get a cable tie around that. Is that going to be long enough? Yeah, just. That will be just long enough here. Just feed that through there. And here's a better angle so you can see it's just going to hold this capacitor in place, look. Nope, if I can just get the thing to go through. Yeah, that cap's going nowhere now. So let's just trim that off. Hopefully it'll fit back in here. Yeah, that's going to be fine. I've pulled that across a little bit there, but it's holding that cap. That cap can't move, so that should do the job. So this little post here, this was broken off. Now I'm going to stick some super glue on this side of it. Hopefully the super glue's not dried up. No, it hasn't. So if we get some super glue onto there, like that, and then stick it in here, push it right down, make sure it's down as far as it'll go. That's it. So it probably needs to be a bit further than that actually. So I did the same thing with that one. So those two posts have been stuck back in. We've just got this one on this corner. This tab here survived, as you can see. The other one broke. So all I need to do now is get a bit of glue around these bits here, you know, the little bits where it's pulled off. You can see 3 of them here. Yeah, little bits of glue around those, some there. I'll leave this corner because this corner will clip in very well, and then it's a case of just pushing it back on. I'm not going to be able to show you this because it's going to be very hard for me to do, I think. And there we go, all done. So the base, as you can see, stuck on very well. It needs a little bit more support on this corner. I'm going to squeeze a little bit of epoxy in there, but also I think just to try and fix these. I should have done these before I actually reassembled it. I can literally just get a bit of super glue in there and then just hold it. It might be useful to stick something over there to cover that gap, but you know what? But there's nothing in there that's dangerous because the main transformer is just completely sunk into epoxy along with the mains connections and everything. So it's not a really big deal if it doesn't glue back together perfectly. But I do know that if I get a little bit of epoxy in there, I might update you at some point in future on another video, but I'll guarantee if I get a bit of epoxy in there, that will be solid. So the other thing you want to check is that you've got 160 milliamp fuse here. You can see someone's obviously been in this in the past here because it's a bit warm, that. Yeah, so 20 millimeter fuse there, 160 milliamps. And obviously check your mains plug. This is not currently like a illegally safe plug in the UK. I would be swapping this out later. Because it should have some little plastic parts around the live and the neutral there to stop kids and things electrocuting themselves, because they've got small fingers on them. They could easily get to those while they're plugging it in. And it's got no fuse. Oh my god, it's got a piece of wire. It's got a piece of wire. I was puzzled then for a minute because I was thinking to myself, how can this be working without a fuse when I've been using it and testing it? It's got a piece of wire. That is a first. That is a first on my channel. So you know what? Yeah, don't leave pieces of wire in plugs. You've got to hope that that's the right rating, but yeah, I don't know. It's anybody's guess as to what rating that would be. It could be 5 amp, it could be 13 amp, it could be anything in that piece of wire. Yeah, so anyway, the plug's going to be coming off, but make sure you've got a suitable fuse in there. Like a 3 amp fuse is more than sufficient for something like this. If you had a 13 amp fuse in there and the main windings in this transformer shorted for the mains input, it's going to literally turn this wire into an electric fire. Yeah, if it's unattended and it happens in the middle of the night, you could burn your house down. So do make sure you've got the right size fuse in your plug, and make sure it's a safe plug. As you can see, this was burn-in tested here in, I think that's 1985. Before I forget, Plan C has just done a really good video on the C64C brick. So it's a solid brick rather than a wedge. and what he did is he removed the internals, the epoxy and all, in one solid mass, and then replaced the innards with modern components. So it's a very good video. Please go and check the link down below. So I hope you enjoyed the video. Thank you very much for watching. Please see the links down below for Patreon and Coffee if you want to support the channel. Thank you very much to all my patrons. I'll catch you in the next video.